Dear Dr. Padma, I would like to submit my homework 1 about correct data of temperature and ultrasonic sensor by ESP32 IoT dashboard. ESP32 is a series of low-cost, low-power systems on a chip microcontrollers with integrated Wi-Fi and dual model Bluetooth. Like this picture, we can use the 4 pins 2 ultrasonic sensor, and you can get the 3 pins to connect the temperature and humidity sensor, like this, the DHT11. For the GPIO12 to connect the economy pins, and the 13 pin connect the triggers pins. For this, the left is DHT11 sensor. There have 3 pins. The one for VCC to connect the vantage. The pin is ground. Connect the ground. The pin is data to connect the GPIO4, the fourth pin. For this is the ultrasonic sensor. Number is HCSR04. There have 4 pins. This one is VCC to connect the operating voltage, about 5 to 0.5 voltage or 3.3 voltage. This one is ground. The 2 pins, one is string, 4 send the signal. One is the equal pin to receive the signal from set and receive. Send and receive, plus and plus to equal the distance. For the DHT11 is a basic low-cost digital sensor used to measure temperature and humidity. It's commonly used in electronics projects, particularly with microcontrollers like Arduino. The sensor consists of a calibrative humidity sensor and a thermistor to measure the surrounding air and output a digital signal on the data pin, often used in weather stations, environmental monitoring, and other DIY electronics projects where monitoring of temperature and humidity is required. There have a 10K register from data pin to the power pin of the sensor. And the ultrasonic sensors have been a step in the sensor space for several decades due to their convenience, flexibility, and low cost. We will above the home adult range of 20 kHz. These ultrasonic chips pulse from nearby objects and return to the sensor. By measuring the amount of time that it takes for this send and receive process to occur, an object's distance from the sensor can be calculated. For this is the control program by Arduino. First, for the row 1, it means includes the single label for ESP32 that connecting to single for an IoT platform. For this, include DHTH. It means includes the DHT sensor library, which is used for reading temperature and humidity from DHT11 sensors. And this lines define constants for the single username, device ID, credentials, and the SSID and password of Wi-Fi. In order to connect the ESP32 to the single platform and the Wi-Fi network. For the row 8, it means creates an instance of the single ESP32 class, which manages the connection to the single platform using the provided credentials. For this, cost into pin equal 30, and the int pin equal to 12. The 30 is the trigger pin to connect the 13 pin on the ESP32 board for the send the data, and the 12 is the equal pin on the ESP32 board for receive the signal. For the 12 and 13, let's define the pin 4. The pin 4 to connect the data of DHT11 sensor, and define the type to the DHT11. Define the DHT variable for the pin and tabs, because the pin and tab defined before. For the weld setup, Serial is 115200 and defines the 14 pin to output on the ESP32 to connect the LED net. The LED for the 20 row. The LED for the pin 14. It means the single resource LED to GPIO 14 over the ESP32, allowing remote control of the LED connected to the pin via symbol. Like this. This is the physical connecting. From 21 to the 13 rows. This thing ultrasonic. This thing temperature. This thing humidity. This nice set up resource on the single platform to read the distance data, the temperature, and the humidity data from the ultrasonic sensor, and the two is the DHT11 sensor. When these resources are accessed, they read the sensor values, send them to the single platform, and this define the pin show values. Now higher is the trigger pin and equal pin to send the data and receive the signal, and provide the sensor values to the serial meter. For the temperature and humidity, we will define float T read from temperature sensor of the DHT11 and the read humidity signal from the DHT11, and define the T is out value. The H is out value, and print the sensor values to the serial meters. For this is the degree centigrade. This plus the percent, and all print for a new line. For the word loop, sync handle. It means that it can be kept the single connecting alive and handle any incoming commands or data requests, and detail 0.1 second. The microsecond 2 centimeters is mean the distance how to connect it and how to show. The distance equal to the 29 seconds per centimeters. When I vary and uploaded our the program, they show as the I don't know like this. This is the distance, the temperature, the humidity. Like this, that shows video of DHT11 sensor to show the temperature and humidity is working by Arduino software. When uploading down, we can see the distance, temperature, and humidity data shown in the serial monitor. For the single I/O platform, the single I/O is a tool to create connected products. It allows you in a fast and easy way connect any many device as you need. It's a cloud IoT platform, not called need. Handle any device from a single platform. Collect all the data and unify the matrix. No matter what or how many devices you have, it just works. Turn data into insights, connect the store your data into the platform, and create dashboards with custom or built-in value. Share dashboards with your customers. Next, we will create an IoT-based embedded system. Like this, we can use the left show in the single I/O platform. From the device and the dashboard, we can create the username. And if we create devices, when I work in the program, we can use the APO control the sensors to LED turn on or turn off, and collect and record the temperature, humidity, and the distance. For example, in the dashboard, we can change the white gate on the right up. In the white gate settings, we can set the title name. For our program, the title name like this. The name is this. We can set it this. And we can set the background in there. The type we can choose. For this, we usually use the progress bar, the tachometer, the text value, or the donut chart. This is the text value. This is the tachometer, and this is the progress bar. I can See, I can make an example for the progress bar like this. In the progress bar settings, if we finish the table choice, we can set the data source, choose the from device resource, and connect the program is this, and click or choose what show the source, like humidity, temperature, and our ultrasonic. For example, we have choose the temperature. We can set the refresh mode. We can set 1 second or 1 minute or 5 seconds or 1, 2, 5, and 10 minutes just for you. And in the wide gate setting display options, the units we can make parameter same percent and the degree centigrade. Like this, the distance unit is cm, centimeter, and the humidity unit is percent. The temperature's unit is degree centigrade. And we can set the range value from 0 to 100, and you can change this. Because, for example, we can change it from 10 to 1000 or 500 and so on. Then last, we click the saved. The same and we can see the show on the dashboard like this. LED 1 of state, the temperature, ultrasonic, humidity, and then another temperature, another ultrasonic, another humidity, and another this, like this, and so on. Like this, that shows video of DHT11 sensor and ultrasonic sensor are working in single backbone API part like this. Next, we can show the video of the DHT11 sensor and ultrasonic sensor work in single platform dashboard part. We can say show the different type of ultrasonic temperature and humidity. And we can change the distance and the temperature data. If I touch the DHT11 sensor, we can see the temperature and the humidity data is different. Okay, this is my introduction of my homework about connect data of DHT11 sensor and ultrasonic sensor by ESP32. Thank you, sir.